Welcome everybody. In this video we are going to add a goalkeeper to our soccer game. We will also add the possibility to perform a throw-in and tackle other players. Finally, we will add some typical soccer statistics to the game. Let's start with a small exercise. When we hit the post, like over here, we see that the ball is already bouncing back, but there is no sound. It would be cool if you could hear a sound if you hit the post. So I added this sound over here. And now we want to play that sound as soon as you hit the post. I'll give you a minute to think about it. So if you want to pause the video, you can think of a solution yourself. So, well, if we take a look at the goal, we see that we have this object called pole. It has a mesh collider, so that's why the ball collides when you hit it. What we can do is add a script over here. So I'm going to my scripts folder and create a new script called post. Okay, so I've opened this file and I'm going to create a variable audio source. I'm gonna call it sound hit post, and then in the awake function I prefer to use the awake for that, not the start. Then we can select the sound to initialize it, and then we can use the on collision enter. Function to play the sound. So as soon as something collides, and the collider that is attached to the same object that the script is attached to is used, then we will get into this method and the sound will be played. Now if we attach this post script to the pole object, and let's just attach it to the second pole of the second goal as well. Now as soon as the collider is hit, we go into the on collision enter of this post script, and we use that to play the sound. So let's check if it works. Yes, you can hear the sound, so it's working perfectly. We are going to add a throw in and the ability to tackle other players. But before we do so we need to organize things, because things get very complicated with so many actions going on, and if something goes wrong, it's very hard to find the reason. So it's very hard to debug the game. So therefore we need to keep everything very well organized when creating a soccer game. So what I did is I create this player action. In here we have some actions that the player can perform, like throwing in the ball and tackling other players. And then this action involves some animation, but also some action at some stage. Sometimes the action is immediately when you press a button, but it can also be with a small delay. With this code you can handle all the possibilities what to do with actions. So we handle the animation over here, so we can set some stuff there if it's necessary. You can fade in or fade out an animation, and once the action is finished you can also execute some code. For example, you can log a message like over here, and we also have code if the action is started, so you can put some code in there if you want, and usually that's used at least to start the animation. And we can play animations from the start, or we can play them with a delay, or start them a little bit later. And we can also terminate any running actions if that's necessary, because we don't want to have side effects from actions that are still running and cause certain effects. So this is where the action is actually executed, and then we call back to the code that is in the player object. So for example, if you take a shot, we first start the animation, and at a certain point the ball needs to be shot, so that happens over here. So that's when the delay is passed, and then we take a shot and change the game state. We also have some things we can do during the update, so when the action is running, if that's necessary. For example, for the goalkeeper, you will see that is very useful. Now if you take a look at the game states, we have different states. We can be playing the match, we can be starting the match, so it's a new match. We can be bringing the ball in, that's doing a throw in or a goal kick or something. So that's one state for all of those events, because they are very similar in behavior. Yeah, you can see we can be cheering, so that's all different states, and we can separate those states and do things there that are necessary only in that state, but not in any other states. That way we can keep the code within certain limits without using heaps of if statements everywhere. Alright, and what we're also going to do is we now need to use inheritance. Fortunately, the C# language offers a lot of advanced features to create clean code. One of them is inheritance. I made some schema of how this looks like in our game. We have a player object where we handle all things that the player should be able to do, like shoot a ball and stuff. Then we have a human player. This human player has that stuff from the player, but also some extra functionality to check, for example, if a key is pressed. If you want to shoot, then you shoot by pressing a key, and that code is in that class. And then finally we separate also the human player by a goalkeeper and a field player, because a goalkeeper needs to do different stuff than a human field player. So that also involves different code. And the same goes for the AI player. Here is actually in this class is a lot of logic how the AI should behave. So what the PC player should do when he is defending or attacking. Does he need to move to another player? Does he need to shoot? All kind of things. Everything that controls the AI is in these two classes. So if you take a look at the code, you will see that if we go to that human field player, this class is inherited from the human player. And the first thing we do, because C# doesn't do this automatically, but we explicitly call the base class to execute the update function in there once we have an update for the field player. So if we go to that base class, that's the human player. This is also inherited from the player, and it also calls the base update function. So if we go to that one, you'll see that this code is always executed if you are a field player, but also if you are a goalkeeper, because the goalkeeper also inherits from the player object. So in this class is just inherited from owner behavior, just like any other Unity script. For the throw-in animation, I'm using Mixamo again. This has a throw-in animation. It's not completely exactly like I want it to be, but it's usable. So we'll take this one. We download it as a Unity FBX, and we download it without skin. I've opened the FBX file in Blender to show you that this animation uses the humanoid skeleton. You can see that there are a lot of bones and a lot of joints, and they are moved. And so because of this this humanoid structure, we can apply this animation to any skin, any mesh that has that humanoid bone structure in it. So if you take a look at the animations, for example the throw-in, you see that we have rigged it. We rigged it as humanoid, and we have used this avatar for that. And if you open that avatar, you'll see those that bone structure again. So this is how the animation is mapped to these bones. And if you open the player prefabs, then you can see that over here we have this structure as well, only it's prepended with Mixamo Auric everywhere. That's something that the Mixamo export did for us. So the Unity needs to be able to map this onto the proper proper joint in the animation. So therefore, if you take a look at the avatar that I've used over here, that is not the standing idle avatar, but that's the avatar that is specifically of this character. So I extracted the avatar, and then I attached that over here. So that way the animation works. So if your animation doesn't work after you've imported it from Mixamo, you probably need to use the avatar of the character you just downloaded. So over here you see that now we have this Mixamo Auric over here everywhere. So now we know exactly where to find those bones in our prefab, and then you can animate it. So the avatar is the connecting thing, let's say, between the animation and the actual mesh that we're using over here. So how does the throwing work? Well, when you are doing a throw-in, you can either pass the ball to another player, or you can just shoot it, and it will be in the direction that you're facing with the power that you just set with the power bar by keeping the button pressed for a while. And what happens then is that we use that player action functionality. So if you go to the player action, and we will start the action, and it will be a throw-in, then you will see that we play the animation of the throw-in, but we play it not from the beginning, but from 40% within the animation, because the first part is not very useful for me, because this player is actually running while he's throwing in the ball, and I want him only to stand still. So that's why we use that last part of the animation and not the beginning. So, and then the animation starts playing, but the action isn't immediately taken. It takes a delay of 1.0 seconds, and after 0.1 second, we start the action, and that's performing a shot, just like shooting with the feet. So, but how does the ball then stays in the hands of the person who throws in? Because if you look at this motion, this ball makes a very complex motion, so you could program that, or you could record something for that, or you could include the ball in the animation and then use that instead of the normal character. But what you can also do, and what's the most easy option actually, is that we have the position of those hands. Because if we go to our prefabs, you can see that there is like I think it should be in here somewhere. You can use the hand, and I added this ball hand position object that's over here. So, and that just follows the hand because it's a child of the hand, so it moves along with the hand. So the ball stays perfectly in the position of the hands when we're performing the throw-in. So the code to stay with the player his hands is over here. So we follow the hand during the action, and once the action is executed and so the ball is actually released and shot, then we stop following of course the player his hands, but the ball moves its own way. And here you can see that the ball moves along with the hands and is shot as soon as it's released. Another thing that I've added to aid in troubleshooting is add these locking lines. So if something goes wrong, we can read these log events and we can see what actually happened that led to that event of that wrong situation. So that's very useful for debugging, because the soccer game is very fast, a lot of things are happening, and you want to know what is the situation when something goes wrong and you see something in the screen that's not supposed to happen. We just use the debug log functionality of Unity itself, only I've added this class so I can define topics, and I can activate certain topics. So all the topics over here are now activated, and I can leave out some. So then if the logging gets too big, I can just focus on the part that I'm interested in. So for example, if something's wrong with the player, I can just use the player events and see what happens over there. And I can leave out the other ones so I have a more clean log and can read it more easily. I want this game to be as easy playable as possible, so I'm only using 2 buttons. We use the left and the right mouse button. So when you have a ball, you can use the left mouse button to shoot and the right mouse button to pass it to another player. But if you don't have the ball, you can use the right mouse button to switch the active player, but we still have this possibility to use the left mouse button, and we can use that to perform a tackle to obtain the ball from the enemy. For the tackle we use an animation and also a fall animation for the person who is tackled. If you take a look at this code, this is for the left mouse button, the shoot key. If you don't have the ball and you're a human player, then you should tackle the opponent, unless you are the goalkeeper. The goalkeeper is not allowed to tackle. If you remember the inheritance, this human player class has 2 classes that inherit from it, the human field player and the human goalkeeper, and this way we can check if it's not a human goalkeeper. But if it is a field player, then we perform the tackle. We use the player action for that again. And if you take a look at the tackle action, again it plays an animation, it has a delay in it. And once the tackle is executed, we go over this code, we tackle the players. And we do that by looking in the area around the player that is tackling. If there is any players in that area, so it's a sphere of this diameter. So if there's any players in that area, they will be tackled. And so you will hear a sound. And we also set a player action to those players, and that's the one that they will fall. So they receive that fall action, and on this character the fall animation will play, and they will also be disabled for a while. So if you take a look at the code for fall, so this is where they fall. And you can also see that their movement is disabled over here. And once the I think once the animation is over, so here's the animation is finished, then their movement is enabled again. So that's how the tackling works. And over here you can see how we can tackle another player. It's pretty cool, it's almost like a fighting game. And you can use that in your advantage to disable the other player from moving. And what we can add in future, that if you tackle in a certain way, for example too fast or from behind, that you will receive a yellow or red card for that. But that's something for another episode. There are many different ways that you can make a goalkeeper behave in a soccer game. but I've chosen a very simple solution. You can also make him move like a field player, for example, but in my game I've chosen gameplay over reality. So I want this game to be as much fun as possible, and not necessarily be a realistic football game where you can do anything that you can do in a normal soccer match. So what happens in my game is that if you get near the goal and the opponent shoots in the direction of the goal, the camera changes to a position a bit similar to what you see on the screen now, and then you have, as a player, you have the possibility to hit one of these keys. These are the movement keys, and 2 extra keys on the sides of the movement keys. And if the ball, for example, goes into this corner, you should press the Q. And if he goes over here, you should press the W. And so in this way you have very easy control over the goalkeeper, and you can really make a difference by stopping the ball, which gives you a really nice feeling. But yeah, it's not as realistic as possible, but it's very good for the gameplay. You can stop the ball in almost any situation. For example, if the ball would be over here, you could just press this button, so the keeper will move in this direction, but you should push it a little bit later, not as soon as when the ball is coming here. So then as soon as this player, the keeper, starts moving, he will be in this position when he is aiming for this position, but he will be here, and then he will be able to stop the ball. So it's a combination of pressing the right key and having a good timing that makes you able to stop the ball. So in this input system we have added the dive left and dive right keys. That's the Q and the E key. And then if you take a look at the goalkeeper script, the human goalkeeper script, you will see that we have the code to handle the inputs over here. For example, the left block, and every input causes a player action, and this will cause the player to block left. So this starts an animation. And also during the update of this player action, we have some code to move the player around, because he needs to dive into different corners. So the character itself has also be moved next to being animated. Also the position needs to be moved. And that's the code you see over here. I kept it quite simple. I should fine-tune it a little bit, maybe to make it look even more realistic. But at least at this moment the keeper can reach every corner of the goal. Over here you can see when the goalkeeper camera is activated. So we have the goalkeeper camera over here, just behind the goal, and this camera is activated as soon as a ball is shot by the opponent in the direction of our goal. So we check the position. If it's close enough and the speed of the ball is high enough, and the player that last touched the ball is the opponent, then we will enable the camera of the goalkeeper, and we will also activate the goalkeeper, so we can use the controls to control the goalkeeper and make him move left and right. And as soon as another player receives the ball, or the goalkeeper, then we disable the the goalkeeper camera again. In order to find the proper position for the camera, you can have the game and the scene window open next to each other, and then while running the game you can adjust the scene camera, and you can finally copy the value of the position, and then when you stop the game you can paste the position back in. I've created this extra key, a test key. I use the key T, and then I can perform some test action just to quickly test situations and fine-tune the game. So this test button now takes care of executing a penalty. That's something we can use to test if the goalkeeper controls are working like we want to, and that's useful in future as well. If you can get a penalty, then we have that code for that already. So we have a separate game state now for the penalty. We have a player who is taking the penalty, and we have code over here to prepare for the penalty. So that makes the ball move in the right spot and moves the player to the penalty spot. And then we have also code to take the penalty. For the AI player to take the penalty, we set a random rotation, so we shoot in left or right corner. We tweak that a little bit to make sure that you can sometimes also miss the penalty, that you shoot next to the goal. So we do that by setting the player transform rotation. That makes also the ball shoot in a different direction. And then we simply take a shot with also a little bit of a random value. So one time he shoots faster than the other time. To find the proper range for the shots of the AI player, I've added a debug draw line, and then I try different values for the rotation, and I want to use the range where you can just shoot the ball next to the goal, or you can hit the goal, and at randomly we choose a rotation within that range. So sometimes the AI player shoots the ball next to the goal, and sometimes he hits the goal. So what happens if the ball gets near the goalkeeper? Well, we measure the distance to the goalkeeper from the ball, and if it's close enough, then we count it as a shot on goal. And if the speed is less than a certain value, then the keeper can catch the ball. But if the speed is higher, the ball will just bounce off the goalkeeper. The final thing I want to show you is the statistics. I've created a new canvas with statistics, and as soon as the game is over, we will show the statistics. It's always fun to have some information about what happened during the game, and it's I think a useful addition, and every soccer game should have it. So we have the ball position, that is how much time you have the ball, and how much time the ball is on the half of your team. If the ball is a lot on your half, that usually means that you are in defense and the opponent is probably stronger. The number of shots you performed, the more you have, the better, of course. And the shots on goal, this tells you how accurate you were with your shots. And finally, the amount of corners that have been taken. So if you take a look at how we can measure these values, I've created a stats class that contains all of this information. The goals we store in a list, and that list contains goals objects. They are the name of the player and the time that the goal was scored. So that list can contain nothing, or maybe even 5 or 6 if you have scored 5 or 6 goals. So let's first take a look at ball position. How can we measure ball position? We have this game script that's running all the time during the game, and in the update function of this, actually for this we won't use the update function, but we will use the fixed update, because the statistics updates don't need to be faster on people with a faster PC. It can be just like this, 50 times a second, that we update the statistics. So this 50 times a second, we check if we are playing the game, and taking a penalty also counts for playing. It's also playing time. And then we see if the ball, this is actually for the possession, is this part. So we check if the player with ball is in team 0, then we set the team 0 stats, the ball position, we increase it. So if we use an integer data type to store the ball position and the ball on half percentage, because integer is the most efficient data type to use in C#. So we just count every 50 times a second, we count if you have the ball, and then your ball possession increases, and then we can finally calculate the ratio of your ball possession against that of the other team. So we can check if we don't run into any limits here. We see that the maximum value of an integer is this. If we divide that by the number of times a second that fixed update is called, we get this amount. If we divide that by 60, we get the amount of minutes we can record the time. And if we divide that again by 60, we can see how many hours we can actually, how many hours our game can last before the integer runs out of its limits. So it's safe to use this this increase of the counter in the fixed update function, because our game of course will never take any longer than 45 or 90 minutes, and actually our game takes much less, because we don't want to play as long as a real-time soccer game. So yeah, and so if we take a look at the fixed update function, you can see that the ball possession is increased if you are the player with the ball, and your team is the player with ball actually. Then your team stats, the ball position is increased. And for the ball in half, we check where the ball is. If it's on the half of the one team, his ball in half gets increased, and otherwise the other team, his ball in half value gets increased. And then if we want to display these stats at the end of the game, you can see the code over here. I didn't create references because there's a lot of objects that we use to fill in the text, but we can just use this fixed position, because if you take a look at the canvas game over, you can see this this structure. So we simply find that game object with that name, and then set the text to the stats that we collected. And if you then take a look at the ball possession, we calculate that over here. So we counted our own ball possession, and we divided by the ball possession, the total ball possession, let's say, so the ball possession of you and the enemy. And then you can see if you had half of the ball possession, you will get a half, and times 100 is 50%. So we show that as a value without any floating point results. So as a percentage, an integer number. So for the shots, I can show you how they are increased. If you want to check out how we count the shots, I can show you that if we see the references of this shot element in the stats class, you can see that it's referred to over here in the take shot function. So where we actually shoot the ball, we check, and if we are the team number 0 and we are close to the opponent, his goal, and the shoot direction is in the right direction, the direction of the opponent's goal, then we count that as a shot. So there's actually 3 things you need to do. You need to be in the right team, you need to be in the right area of the field, so close to the enemy goal, let's say for in this area, and then you need to shoot in this direction. Then it counts as a shot. And if we take a look at the shots on goal, a shot on goal is actually if you shoot somewhere in this area, but that's kind of hard to calculate. Then we need to, with every shot, to pre-calculate if it would be inside the goal or not. Actually, you could say that we then need to first simulate it as if there is no goalkeeper in between, and then see if it's a goal. So then it's a shot on goal. But we don't do that. I'll show you. If you scored a goal, then of course it was a shot on goal. So that we calculate as a shot on goal. But also if the keeper takes the ball, then that's also a shot on goal. So if it's a goal or the keeper takes the ball from your shot, then it's a shot on goal. The amount of corners we can easily track by looking at this code and adding the counter over here. In the ball script we already have code that's checking if it's a corner or not, and we can use that to track the stats of that. And finally the goals. You can see over here, if we score a goal, we get into this code, and there we add the name of the player who last touched the ball. That's the player who scored the goal. And we also record the time that we have in the game timer as a text. So and that's also always in the 90 minutes range. That's the actually game soccer game takes, so that gives us a realistic timing over there. One thing to take special attention of is if you take a look at the this let's go with the C navigator to the game over canvas, and I'll show you this part where the scorers are displayed. If you put a very small text in here, you can see that it's giving you very big fonts. That's not very nice. If you have one player who scored a goal over here, then you have a very big letters with that player and very small letters of the team who has scored, for example, 2 or 3 goals. Because we used auto size over here, but we want to use auto size because we want to resize this and all the other text as well if we are on a different display, for example on a mobile. So yeah, to make sure that the scale of this part and that part is the same, I've added this code that just creates some empty lines, so there's always at least 3 lines. Unfortunately, I needed to add a dot over here because otherwise it wasn't working. If somebody knows a better way to do it, please let me know, but I found out this is at the moment the best way to display a dynamic list like this in TextMesh Pro. So this concludes our video of today. Our game is almost ready to play now, so in the next episode I will add a link to itch.io so you can try the game for yourself. Thanks again for watching and see you in the next video.